In this video, we're going to be parameterizing ellipses, which if you have not checked out my ellipse video, please check that out first before proceeding to this video, as this video will be an in-depth coverage of ellipses. We know from ellipses that they have a center point, major axes, and minor axes with 4 respective points that we can find from knowing these attributes, which in this specific case of x squared over 16 plus y squared over 9 is equal to 1, will have a center of 0, 0, the major axis with 4 units, and the 3 units for the minor axes. We're going to be taking up the first example within this example of parameterizing this ellipse to start at 4, 0 and travel in a counterclockwise motion, which I'm going to be abbreviating as CCW, with 2 pi rotation. With a 2 pi rotation, that means it will rotate counterclockwise all the way back to the 4, 0, its starting point. And the reason why I know and I can say that a parameterized, or in this case the example, will have a travel direction of counterclockwise motion is because parameterized values have directions. Therefore, this applies true for this ellipse as well. So with this, how are we supposed to parameterize it? Well, the parameterized example of this will be 4 times cosine of theta, comma 2 or 3 of sine theta. And the reason why this is true is because we can look at the theta angles. Theta will always start from 0, or at least in this case will start at 0. And when theta is equal to 0, this will become 4, as cosine of 0 is equal to 1, and 3 times sine of 0, which is 0, will become 0. Hence, we know it will start at 4, 0. And this leads up to our second point of parameterized equations, which are that they must have restrictions. And in this case, our theta must be between 2 pi and 0 degrees, as we are starting from 0 and traveling 2 pi rotation all the way around the ellipse in a counterclockwise fashion, which when theta is equal to 0, you can notice that it will start at 4, 0. And then we can verify that this is true, as when theta is equal to pi over 2, then cosine will become 0, and sine pi over 2 will become 1. Hence, when theta is equal to pi over 2, will be the same point right here, showing you that it's indeed traveling in the black arrow direction, which is in a counterclockwise fashion. And therefore, we have parameterized this ellipse with our first example, or first take-up of this example. And then we have to move on to our third or second parameterized equation, which is I want to start at the opposite direction. I want to start at negative 4, 0 instead of 4, 0. Well, how am I supposed to do that and flip the starting point 180 degrees across the x-axis? Well, we must change our parameterized equation. So previously, for cosine of theta, think about it. When theta is equal to 0, we're going to remain this restriction. We're going to keep this restriction of theta being between 0 and 2 pi. But what will happen to the 4 so I can make it to start negative 4, 0? Well, that answer will be to negate the 4 to result in, when cosine of theta is equal to 1, which when theta is equal to 0, will result in a x value of negative 4. So now that we have that out of the way, we must determine what happens to the coefficient of 3. Because remember, when the coefficient is 3, that means, let's say this is 3 sine of theta. And this restriction for the parameter, this will likewise travel in a counterclockwise motion. So I want to remain that. And think about it, when theta is equal to pi over 2, apply in angles that we know special values for. Therefore, we can find exact values to give us a sense of what direction it is. So when to finish off theta is equal to 0, this will be negative 4, 0. It will start off at negative 4, 0. But when theta is equal to pi over 2, this right here will become 0. And sine of pi over 2 will remain as 3. So that means negative 4 cosine theta, comma 3 sine of theta will result in a clockwise motion right here, which when keeping the restriction of theta will result in a 2 pi rotation all the way back to negative 4, 0, but in a clockwise motion. Therefore, In order to change this to get it to counterclockwise motion, we negate the 3 to get a counterclockwise motion with the range being between of theta, 2 pi, and 0, and traveling counterclockwise all the way back to -4, 0. And these two examples will be sufficient for us to lead on to the next video where we generalize these two scenarios.